So, hello everyone, how is it going? Feeling energized after the coffee break? So, before I start, I have a question for all of you. How many of you have come across these drawing tools like Miro, Figma, Draw.io, and there are so many more out there? Please raise your hands. Wow, that's great to see. This means that these tools are really important. And these tools are really powerful and comes with tons of functionalities, but at the same time, these tools can be overwhelming for a user to start with as well. And it does have some learning curve too. So just give it a thought. What if there is a tool which has all the necessary functionalities, almost zero learning curve, no sign-up process at all, and a great user experience? That would be amazing. That's what we want, right? And that's where Excalidraw, a free, open source virtual whiteboard which helps you to sketch hand-drawn like diagrams, was born. And I am Aakansha Doshi, one of the core maintainers of Excalidraw. So before we dive into the internals, let's have a look how this project was started. So during the lockdown in 2020 is when all of us were stuck at home, Viju from Meta started working on a small side project. And he was really inspired by this app called Zwibbler, which is again a drawing app. And he's tweeted about his side project on 2nd Jan 2020 and got a great response from the community. On 3rd Jan, the repo was set up, it was open source, the domain name was registered, and this side project got its name as Excalidraw. That's how Excalidraw came into the existence. And you would be amazed to see that in the next 10 days, this repo got 1.5k stars and 12,000 active users. This was really amazing to see for a project which was started like a while ago. So next, I would like to share how did I actually got involved into this community. So in my previous company, HackerRank, which is an interview-based platform, we were looking for a whiteboard to integrate. And after looking about dozens of whiteboards, we finalized Excalidraw due to one major reason, its simplicity. During that time, Excalidraw was built as a standalone application, so it didn't really have any integration pipeline which you could use to embed Excalidraw into your application. So I came up with this proposal of NPM package, which would actually help users to embed Excalidraw as a React component into their applications. And but that time, since Excalidraw was at a very early stage and this NPM package thing would introduce a huge refactoring into the code base, so the team wasn't really ready for it. And we were having a lot of back and forth discussions. So it took me some time to convince the team. But in the meantime, I myself got interested so much into this project that I started contributing to it by picking up some good first issues. And in about 4 months, the team was also convinced. We started working on the official NPM package version and we released it, and it's used by a lot of applications. So that's how my journey started with Excalidraw. So now it's time to have a quick look of how Excalidraw looks like. Let's do the demo. Yeah, okay, so you can just go to the browser, type in excalidraw.com, the editor just booms up, no sign-up process at all. You have all the necessary tools for you to get started. So let's just draw a rectangle. Maybe I'll just color it with this color. I'll change the fill. Let me write some text. Maybe change the alignment, left, right. Now I think middle looks fine. So we have the image support as well. So since this talk is about Excalidraw, so let me just pull in the Excalidraw logo here. And we are at the ReactNext conference. So let me put in that logo as well. And we also have libraries, which is basically pre-built drawings, and we have an amazing collection of libraries. You should definitely check out the libraries if you still haven't, and you can even search for the libraries. So let me search for hearts. I really like this one, and this is my favorite. So yeah, this looks good. And let me also link this to the website, right, reactnext.com. Now you have the link here as well, and you can just open the link. So that was a quick demo of what Excalidraw can do for you, and there's a lot more things you can try out. So please check it out if you haven't yet. Now let's go back to the slides. Let's go to the agenda. So we are going to discuss about end-to-end encryption, collaboration, and internationalization. So these are the three major categories we will be deep diving into today. So now, again, I have a question. So whenever you are using an application and you have some data in there, what is the first question that comes into your mind? Data privacy? Whether someone is looking at my data, is my data really safe? These are the questions which come into our mind, right? So that's where end-to-end encryption comes into the existence. So how this works is whenever there is a data exchange between a sender and a receiver, nothing in between, not even the server will have access to the data, which means that the data gets encrypted on the sender's end and gets decrypted only on the receiver's end. And that's where Excalidraw also comes with end-to-end encryption. And before diving into how it internally works in Excalidraw, let's have a look how it actually works in a traditional client server architecture. How does encryption work in traditional client server architecture? So when you have a data exchange between the client and the server, that network, that communication is encrypted with the help of HTTPS. This is awesome, this is great, but you are still storing the content on the server, the raw content on the server. So what if your server gets compromised? Your content could get breached too as well, right? And that would be a nightmare. That is something we wanted to avoid in Excalidraw. So we came up with this model that, hey, instead of sending the raw content over the network, let's encrypt the content first, send the content over the network, and also store the encrypted content in the server as well. So this means that even if your server is compromised, your content is still safe, your content is still encrypted, and that gives a lot of relief, right? So but to execute this in reality, we also need to make sure that you need to hide the encryption key from the server as well. Server should never be able to decrypt the data. So we need to also hide the encryption key. And this was a bit of tricky challenge to solve. But the way it was solved is really interesting. So when you have this hash comes to the rescue. When you have this hash in the URL, whatever data is present after the URL, that is never sent to the server. So why not take advantage of this behavior and store the encryption key right after the hash? And that way, you don't send the encryption key to the server, but still you can share it with the receiver as well. So that's how we went about it also. And now we have two things in place. We are going to store the encrypted content on the server, and we are also not sharing the encryption key with the server at all. But now the third thing is that now the client has to take care of the encryption and the decryption. The server is not playing any role in encryption and decryption process. So how do we do that? How do we encrypt and decrypt the data on the client? So there is nothing to worry about that. Thanks to the web crypto APIs. Thanks to the why is the slide not switching there? Yeah, thanks to the web crypto APIs, and they have a great support in majority of the browsers. So yes, we decided to use these web crypto APIs to build the end-to-end encryption model. And let's have a quick overview to get more about this, how this web crypto APIs look like. So they are only available in HTTPS. So in HTTP, you can't really use it. This API, this vendor.crypto.settle will not be available at all. They have generic APIs. By generic APIs, I mean that they have APIs for encryption, decryption, sign, and all those kind of stuff. But those are not those are not in relation, and those are not separate for every algorithm. You have to pass the algorithm to these APIs, and they'll encrypt the data or decrypt the data accordingly. So that's why we see that it has like the APIs are very generic in that way. It deals with only binary data, which means that it takes the binary data as input and gives the output as binary data as well. So we are going to talk a lot about binary stuff in the next few slides, and we are going to use this array buffer and unsigned 8-bit array, or you say uint8 array a lot in the next few slides, because that's how you deal with binary stuff in JavaScript. And the last is that most of this API will return promises, so we are going to use async await a lot as well. So yeah, that was like a quick overview about how this web crypto APIs look like. And now what we are going to discuss is we have discussed the approach. So now it's time to dive into the implementation, right? So what we are going to do is you have a sender and you have a drawing and you are generating a link for that drawing and you want to share that drawing with your friend. And when your friend opens that link in the browser, downloads the drawing from the server and accesses the drawing, in this entire process, we are going to build the end-to-end encryption model. So yes, I know. Now I think I just talked a lot about the theory. Let's dive into the code without wasting any more time. So let's look at the encrypt API first of all, how this API looks like. So in this, you have various parameters. You have the algorithm, the name. We are going to use advanced encryption standard GCM mode because it's the most authenticated mode and it makes sure that your cipher is not modified by the attacker. We need the IV. I'll come to this a bit later. Crypto key and the data buffer. So one by one, we will discuss each of it, but let's first discuss what is the crypto key and how do we get it. So let's have a look at the crypto key. So we are going to use this algorithm crypto.settle.generate key, to which will actually help you in generating a crypto key. You have to pass the algorithm data and the algorithm name, and we are going to generate a 128-bit key, and that true key is extractable. That I'll come in a bit later, but for now, just remember that this key is extractable, and we are only going to use it for encryption and decryption. Okay. So this API will be when this resolves, what you will be getting is a crypto key object, and this is how it looks like. So you just have the details about that key. You have the name, you have the length, you have the type, and you have the usage. Now this crypto key is basically an opaque representation of a cryptographic key, by which I mean that you can't view the bytes of that key. Not even the developer who generated it can actually view the bytes of that key. So that's where if you want to use that key later on, you need to extract the bytes from that key. And for that reason, we need to set the parameter extractable as true. And then only you are saying that, hey, when you're generating this key, I want it to be extractable later so that I can use the export key API to actually extract the bytes. And if you don't set this parameter to true, then you can never extract it. So that's where we are actually setting it to true, because we are going to use this key in the URL, right? Later on, when we generate the URL, we need this key in the URL as well. So yeah, that was about the crypto key. Now let's see what is the next thing. IV. So IV is basically initialization vector, and how this helps is it basically adds a randomness to the encryption algorithm, making it more stronger and harder to decrypt. And when you have identical blocks of text, it will make sure that it generates a different cipher for those texts as well. So it will be basically becoming harder to decrypt. So that's where IV helps you. And we also need to make sure that this IV, when you decrypt the content, you need the same IV for that with which it was encrypted. So you can't decrypt the content without this IV. So along with the encryption key, you also need the IV. You also need to share the IV with the receiver as well. So that's something to keep in mind, that we need to share the IV with the receiver as well. So now let's look at how we are going to generate the IV. So as I told you that the crypto APIs only deal with binary data. So we are generating a uint8 array of 12 bytes. We are going to generate a 12 bytes in IV. And then we just run this algorithm, crypto.getRandomValues. This is basically responsible for generating strong cryptographical random values. And that's how you get this, that's how you get the 12-byte IV. So now you have the IV, you have the crypto key. Is there anything else which is left? Let's have a look. Yes, data. Data is still left. We have the data, we have that drawing which we are going to share, but that drawing is not really in bytes format. We have it it's like an array of elements which we are going to share. So we need to convert that data as well in the binary format so it's compatible with this API. So let's just do that quickly. So we have an array of elements, we just stringify that data and we just run the encoder over it, and you get that uint8 array, which is now compatible with your encrypt algorithm. So now we have all the three things in place. We have the crypto key, we have the data, and we also have the IV. So what are we waiting for? Let's just go ahead and encrypt the data. So now that's it. What we do, we just run the API and we get that encrypted buffer. So now we have this encrypted buffer. So we have now encrypted data successfully. And now, as you remember, there is still one thing which we haven't discussed yet. The IV is still, we need to share it with the receiver. So how are we going to do that? We still haven't discussed that part yet. So since we are going to upload this data anyways on the server, so why not store the IV on the server as well? So why not make it a part of payload as well? So the first 12 bytes, because IV is always going to be the 12 bytes. That's something which we have decided. So the first 12 bytes of the payload will always be the IV, and the rest will be the encrypted content which we just generated. So you can keep it the last 12 bytes as well. It's up to you, but we are keeping it as first 12 bytes. So when the receiver will get this payload, the receiver will just extract the first 12 bytes to get the original IV. So now we have the payload ready. So let's just upload it to the server. Just do the API call and upload it to the server. This is pretty straightforward. So now we have done the backend part. The backend part is done. We have uploaded, your blob is now uploaded to the server with the IV. Now we still need to generate the link, right? So for that, we need the encryption key, but the encryption key is still in the crypto, is still a crypto object, it's still a crypto key. So as I told you earlier, that we need to extract it so that it can be used in the URL. So that's what we are going to do here, and for that, we are going to use this JSON web key format. This is how it looks like. We haven't yet exported it, but we will do it. But this is how it will look like. So you have the algorithm, you have the extract parameter, and this K is the most important part. This is the key in the string format which you are getting, which you can actually use in the URL. So now that you know the JSON web key format, let's look how the API looks like. So we are just going to run the export key API over it, and we are just extracting that K parameter because that's what we need. And that's what we are storing in the encryption key. So now we have the encryption key in place as well. So let's just go ahead and generate the URL. So that's what we do. We append the scene ID. Scene ID is basically the drawing ID, so don't worry about that. And the encryption key is the second thing, and what we are just appending it to the hash. So this is how your URL is going to look like, and you are ready to share it with your friends. Great. So now we discussed what is happening on the sender's end. The sender has successfully generated the URL and shared it with the receiver. So now what is going to happen on the receiver's end? What will happen when receiver opens the link in the browser? Well, you can actually guess now that it's going to be reverse of all the processes which just happen on the sender's end. Let's have a quick look on what actually receiver does. So the first step is just extracting the scene ID and the key from the URL which is right in front of you. That's the first step. That's straightforward. So you get the scene ID and you get the encryption key from the URL. So now that you have the scene ID, let's just fetch the data from the server. So we just do the API call and just get the data from the server. So now you have the payload as well. You have the payload from the server. So now what does this payload contain? It contains the encrypted blob, but it contains one more thing as well. What is that one more thing? So it also contains the IV. If you remember, we also uploaded the IV. The first 12 bytes of the payload are always the IV, right? So that's something we need for the decryption as well. So that's what we are going to extract now. So yes, you just convert that buffer into a uint8 array because you can't run any operations on the buffer. And then we just take out the first 12 bytes from the payload, and then the rest is the encrypted content. So now we have the IV, we have the encrypted content, and now can we go ahead and just decrypt the content? Are we ready to decrypt the content? Let's have a look at the API. So this is how the decrypt API looks like. We have the original IV, we have the original blob as well. Do we have the crypto key? Do we have the crypto key? We don't have the crypto key because we have it in the string format. It's the extracted format, right? We need to go back to the crypto key again. We need to go back to the crypto key object where you can't actually view the bytes. So that's what we are going to do now. So this crypto key is something which is still missing. So what we do is we just convert it to the JWK format again by adding the extra attributes which are missing. Those attributes we add again, and then we just run this import key API, which is basically reverse of export key API, and it will give you the crypto key object. So now you see the K attribute is gone, the key is gone. So now this key is compatible to be used with the decrypt API. So yes, now let's go ahead and decrypt the content, and that's it. You decode, and the receiver has now the content in front of it, and you have successfully built the end-to-end encryption model. So now next time whenever you are building any app, just give it a thought that whether your server really needs to see the data. If not, then end-to-end encryption is the way to go. So yeah. So now that we talked about end-to-end encryption, where you are sharing a link with someone and that person can view the drawing. What if the person wants to collaborate with you? You will want to collaborate with your friends, with your teammates as well, and especially since 2020s, we are very much into collaboration since we are working from home. So next, I'll be talking about how collaboration internally works in Excalidraw and what are the tools we are actually using, what are the libraries we are using for it. So Socket.io, this is an open source real-time application framework which we are using. And this is basically responsible for handling the communications between the client and the server. So whatever communications are happening, whenever there is some person joining the room or someone is making any change, all the communications will be taken care by Socket.io, and those communication will be actually communicated with the help of events. So let's have a look. Let's have the look at the highlights of Socket.io. So it has real-time bidirectional event-based communication, which means that all the communication will be happening with events, and those will be transported with the help of WebSockets if supported, else it will fall back to polling. It has auto reconnection support, so users don't have to worry about refreshing their page if they get disconnected. It has binary support. So we just talked about binary support a little while ago when talking about encryption and decryption. So in this case, we don't really have to convert that data into a different format to make it compatible with Socket.io. And it has the room support as well. And this is the most important part, because whenever you are creating a link in Excalidraw, you are actually generating a room. You are basically generating a room, and whoever people are joining that room, only those people should be updated about any changes in that room. So that's how this library works, and that's where Socket.io takes care of that room related things. So now that we know that the communication is going to taken care by this library, we don't have to worry about whenever someone is making any changes in some drawing, there will be an event emitted by the client. The server will be listening to that event and make sure that those changes are broadcasted to all the clients. Those things are handled by Socket.io. But what about the data? What about updating the changes? Or what about making sure that everyone sees the same drawing? Everyone sees we resolve the conflicts, or we resolve the new elements which are added by someone correctly. So we need to take care of those scenarios as well. We need to make sure that everyone is on the same page when they are actually collaborating. So let's have a look at how data is handled. So this is the bare minimum structure of an element. It has the type, it has the XY coordinates, and the rest are the other properties which will get added as you add more features. So now let's have a look on what happens when new elements are added. So when you start adding new elements, let's look at this scenario. So you have two users, and user 2, as you can see, has added a new element D. So now when user 1 gets the notification ahead that, hey, these are the new remote elements which are added, and how will one user 1 understand that, hey, I do have ABC, but I don't have D. D is something new. Right now, there is no way for user 1 to actually identify. And one more thing is that Socket.io makes sure that the client who has generated the event that client doesn't get notified. So in this case, user 2 has generated the event of adding a new element, so user 2 will not be getting any notification. Only the rest of other users will be getting. So in this case, it's hard to, right now there is no way to distinguish the new elements and the existing elements. So what we did is we introduced ID. Now what this ID is basically unique for every element. So now what you can do is you can maintain a local cache and compare it with the remote elements, and whatever the diff is, those are new elements for sure because those were not in your cache. So that's what happens in this case as well. If you see, for user 1, local cache is ABC, and when they fetch the remote elements, user 1 sees, hey, D is not in my local cache, so it must be something new which got added recently. So let me just append it to my existing drawings in my canvas. So that's how user 1 will also see ABCD, and user 2 anyways has updated the drawing. So now the drawing is synced between these two users. So yes, adding the new elements will now start working. Great job. Now, this is not the only thing which we are going to do when we are drawing. You want to also edit the existing drawings as well, right? You want to edit, you want to delete as well. And those are also one of the common scenarios which we need to take care of. So let's look at this. Let's look at how we are going to deal with conflicts. So when elements are edited, let's look at the scenario. So user 2 is basically trying to update the background color of circle. So now we have ID. So when user 1 will get the new elements, user 1 will compare, hey, ID is same in my local and my remote. So I didn't really see any difference. How do I know that, that the remote has the latest state of circle? That is something which is hard to identify. So we need something in our data structure to identify the latest state of an element, which ID cannot do right now. So we introduced version. Now what this version does is, whenever you are updating any property of an element, this version will start incrementing. And now when you have the local cache and you have the remote elements, just check on the version, and whichever has the highest version is definitely the latest state of the element. So now look at this. So now if you see, in both the cases, if you see the square and the diamond, the version is same. It's 11 and 20. But for the circle, if you see, the version is 15 for user 1, but for remote, it's 18. So definitely the remote is the latest version of circle. So let me just replace my local cache with the remote circle, local circle with the remote circle. And that's how user 1 will also see this drawing. So now the editing elements will also start working. So now the next thing is, how do you take care of deleting the elements? So in this case, let's look at this scenario. So when you have two users and user 2 is actually trying to delete the element, now we have this version. But now when the user 1 tries to fetch the remote elements, you can't use this version to actually recognize which elements are deleted. You can see that, hey, the remote version is higher for element B, but I still don't know that it's deleted. How do I recognize that it's deleted? So we introduce this attribute called is deleted, which indicates that your element is deleted. And now if you look at this one, you see that for A and C, the version is same, so no change is needed. But for B, the version is 20 for user 1, and for remote it's 21. And now it means that there is some change happened on the remote. So now if you check the is deleted is set to true. So that means that someone deleted this element B in the remote. So let me just remove it from my canvas as well. So yeah, that's all about collaboration. And we did a deep dive into collaboration and encryption. I think I'm out of time to cover the next topic, so I'll actually skip that topic. And I would like to share how we are actually doing, how is Excalidraw doing so far, and what is happening with it. So let me just look at that one. Yeah. So how is it going? So it's going great, and thanks to all the users for the continuous support and feedback. And we also have now, a company was formed on May 2021 to even promote the usage of Excalidraw. And we have now a dedicated team which works on improving the editor. So if you have any questions or any ideas on how we can make the editor better, let's talk about it. I would also like to give a huge shout out to all the contributors who have helped make Excalidraw what it is today. And I would also like to say some of your names in this list as well. And yes, That's all for today. I think it's time for me to now sit back and relax the rest of the talks. Thank you for your time. And if you have any questions or any feedback, let's talk. Thank you.